Hi, everyone, and welcome to another episode of Pathfinder, a podcast by Payload, the leading digital media company in the space industry. My guest today is Karthik Gollapudi and Austin Spiegel, the co-founders of Sift, a startup developing a telemetry stack that improves how machine data is recorded, visualized, and interpreted. Both former SpaceXers, Karthik led flight software ops for the Dragon spacecraft, and Austin was responsible for the telemetry system on Starlink. A lot for us to discuss, so let's get started. Karthik, Austin, welcome to the show.
Thanks for having us. Hey, Mo.
Yeah, thanks for having us, Mo.
Let's jump right into it. Tell me what you guys are building at Sift.
So I would say what we're doing is building all the software tools for building complex machines. Specifically, we're mostly focused on everything related to telemetry. So end-to-end ingesting all the data off of complex machines, giving you tools to visualize it, do data review, roll that up for reporting and certification, and collaborate with your team on it.
How did you come up with the name?
The name Sift?
Yes.
Oh yeah, that's
I asked because I'm like, I feel like I'm a little bit part of that story because I remember when you were named something else, and you guys had a little bit of a decision to change it. So I just want to we can get into that a little bit.
Yeah, of course. So we had this name Azimuth. That was the original name for it. And one of the challenges is that almost anyone outside of aerospace never pronounce it correctly. I've seen like Azimuth, and then I've seen people just like don't even bother trying. And I was a little surprised about that. But we ended up choosing a name that I think Austin and I both put our inspiration and our ideas about how we want this to kind of feel and like the look and feel of the name. And my inspiration for it was, I said, if you were to build the equivalent of a Porsche, but for the movie Dune, that's kind of the vibe I wanted. So something that's like precision, high quality, premium product, but also in like Dune. And that's where, if you notice, like even like the logo and everything, it's like kind of has these like, was actually the logo has these like telemetry, like a sine and cosine wave overlapping, and it feels a little bit like an S. But then it's like, I think the premium aspect, if you notice, like the Porsche logo is like kind of squatty or like a little shorter, and wide. So it's like a lot of presence. That's kind of like what we did here with the Sift as well.
It sounds like you need to in a previous life, you were like a design guy or something.
Honestly, it was one of those things where it's like, I think I was part of that era of those kids in high school that watched The Social Network and then basically all wanted to make your own little startup, and you're on those Facebook groups like Hackathon Hackers and everything. And then at that age, you kind of just have to do it all yourself. You have to do like the design, you have to write the code, you have to do come up with ideas. So I think there's like a little bit of all of that.
Well, I'm going to reveal something very scandalous, which I've never told anyone in the industry before. But when you guys first were named Azimuth, you had a blue like flight tag, or like it was like remove before flight type like keychain. And I typically don't like use those or have those, but I really liked the color scheme of it, and it matched my away navy blue suitcase. So it's been like tagged on my navy blue suitcase. I still have it today. Like there's an Azimuth flight tag, and actually people were like, "Hey, I don't know, man. I don't think you should have that. Like as a member of media, you shouldn't be like rocking like the swag of like a specific company." But then once you change your name, I was like, you know what, I'm just gonna keep it. Like it's kind of like an if you know, like if you're like aware of the old name, then like you'll be able to spot it. But otherwise it's like kind of like this, obviously it's not, you guys aren't named that anymore. Anyway, I loved how it looks, so I still have it on my tag on my bag, and I intend on keeping it.
Well,
yeah. It's funny, we're actually like still looking for some of those because now they're collector's items around the office.
Well, I got one. I'm not giving it up.
Yeah. Hold on to it.
But I do want to talk. You guys have two very interesting backgrounds. Tell me a little bit about like kind of the origin story behind Sift. Why did you decide to pursue this? I know both of your kind of backgrounds lent itself to like coming together to building this. So maybe talk a little bit about
that. Sure. Austin, you want me to take this?
Yeah, you can start.
Cool. So background also, for context, Austin and I worked together at SpaceX back in 2018. Fun fact, we were actually both at USC in computer science, yet we never met each other there because I think we were both offset by like 1 or 2 semesters of doing our CS classes. So we were always offset by that amount. And we met each other in 2018 at SpaceX. And I think there was always like some level of mutual respect for each other. since Austin and I both had like this broader interest in, I think, a little bit more of like startups and new tech while we were both there. And then we ended up splitting teams. I went to the flight software org, worked on simulation software, and Austin, I'll let him share exactly what he was doing. But we left, and then back in 2022, we reconnected because Austin had left SpaceX already in 2020-ish, 2021, something. He basically left SpaceX and then went to Riot Games for a bit, came back and said, "Hey, Karthik, I'm looking at a few different startups. They all are really interesting, kind of curious to get your perspective." And I was telling him that one of the big issues that I've noticed just being working on Dragon was a lot of the tooling we use to go test and do data review and ensure that this vehicle is operating nominally. A lot of that tooling it doesn't exist in the broader market. So a lot of people end up having challenges with building complex machines. And we see a lot of these with the different accidents we hear about with different spacecraft and with lunar landers. So I mentioned this to him, and Austin's like, "Oh, that's really funny because for the companies I'm interviewing with, they're trying to get me to go build some type of telemetry tooling." And I thought that was I thought that was an interesting data point. So I was like, why don't you just go build this for all of them? And I think one of the challenges that we had was Austin knew how to go build this. It's like application software, but it's actually like a very high data rate infrastructure, much more of like a Silicon Valley style problem than like what the type of thing that you would find in a hardware company historically. And from my experience, I was working in flight software, so it's like embedded C++. So I knew how to use this as a user, but I didn't necessarily have the skills to go build this. Whereas Austin had the skills to go build this, but didn't necessarily know a lot of the user workflows, how you're building and testing machines. So I think what we did is we were speaking with some other folks, some other companies, and learned about how they're solving these problems today. And after speaking with 17 companies, we were like, wow, this is crazy. I think like something like 14 of them needed something. And that's when we had a significant amount of conviction that somebody needed to go build this. And sorry, I guess I jumped ahead a little bit. Austin didn't get to introduce himself about what exactly.
Yeah, Austin. Austin, tell us about your Riot. I want to hear about Riot Games. What did you do there?
Oh yeah, for sure. Well, so Riot, I was an engineering manager building dev tools for a game called Legends of Runeterra. So if you're like a Magic fan, this was Riot's version of Magic in the League of Legends universe. Awesome company, great cafeteria, great campus, a little too slow paced when in comparison to SpaceX.
By the way, are we talking Magic the Gathering?
Yes.
Yeah,
yes.
I was a big Magic the Gathering guy in middle school into high school, so
nice.
I feel that.
Yeah. Did you ever play like Hearthstone? Because basically it's very similar to Hearthstone. That's Blizzard's version of this game. Yeah. So and there were a bunch of SpaceX people who went to Riot. So Riot is kind of a place where SpaceX people who are burnt out go to recover. And then people, either leave after a couple of years because they want to go back to grinding, or they end up staying. So in my case, I left to found a company. But prior to that, I was at SpaceX. Actually interned at SpaceX. Funny story. Met Elon Musk in college. I was in a student organization with 20 people. We invited Elon to come to dinner with us at 5 p.m. on a Thursday night, and of course, he actually agreed to it. This was 2014. He showed up an hour late, but he had dinner with us. He was great. Took a photo with us, answered our questions, and then I found out afterwards that his chief of staff told us, actually, when we were doing the fundraising 2 years ago, we met his chief of staff. The chief of staff told us that was the last time he ever let Elon agree to do an event like that, because Elon's calendar was just like too crazy, and going from Hawthorne to downtown LA at rush hour took them like an hour and a half.
Oh wow!
Yeah. So that was kind of my intro to SpaceX, and then during my time there, worked on all sorts of internal software. So everything from manufacturing and test tools to building Dragon, Starlink satellites, Falcon rockets, to telemetry software and commanding software for Starlink satellites. And then I guess left for Riot. After Riot, Karthik and I reconnected, and kind of funny story. Do you know Scott Norman at Earthrise?
Mm-hmm. Yep.
He's also a fellow New Yorker.
Yep.
Yeah. So I was at a first residence recruiting event, and Scott Norman had an Impulse shirt on. So I walked up to him and asked him if he worked at Impulse Space, because I was pretty excited about Impulse Space at the time. And he said no, but he had a VC fund. And this was basically a couple of weeks after Karthik and I had first had dinner discussing the idea for, what is now Sift. And I pitched him this idea, and he was immediately sold on it. And then he helped kind of introduce us to a lot of other folks in the kind of XSpaceX network. And that's how we assembled all that.
That's awesome.
Research that Karthik mentioned.
So maybe let's talk about the product a little bit. Like, walk us through the Sift kind of architecture. How does it work? Maybe without getting too technical.
Yeah, I'm happy to take it, Karthik, unless you want to go.
Yeah. You can go ahead and take it.
Cool. Yeah. So without getting too technical, I think there are a few core parts of the product or the architecture. So one is ingestion, right? How do we scalably ingest millions or tens of millions of data points per second from customers? And in comparison to observability for software, where maybe you're sampling your CPU once every second, in the hardware world, if you're testing a rocket engine, for example, you're sampling your sensors. So you're taking measurements thousands or tens of thousands of times per second. So there's a much higher volume of data. The next thing is analytics. So we do near real-time analysis of data as we receive it to provide engineers with the most immediate insights into their data, right? So as they're testing something, they can see what is going on within their vehicle or within their device, and then they can make critical decisions about what they should do. And in some cases, avoid disaster, which we've been able to help our customers do. Another thing is, so after we ingest, we analyze and we store the data. And I think some unique insights that we have is, most data that is written is never read. And if it's read, it's really read within hours of being written. So that meaning when you run a test, people look at that test data maybe hours or days afterwards, but then they have to store it forever sometimes because of compliance, right? So what were the storage requirements for NASA?
For storage requirements? Oh, you mean how long?
So
retention. Sometimes you want to keep things for perpetuity, but I think typically for government contracts, it's somewhere between 5 to 10 years. They have to retain the data. Right,
but that data is rarely looked at. So really, what our insight is if you have to store that data for a long time, but you probably are not going to look at it, and if you do look at it, you look at it almost immediately. You kind of do the math and realize what is a proper storage class to store this data in to save money. And then finally, there's, of course, the interface, right? Which is purpose built for hardware engineering use cases to visualize, analyze, and report on that data.
So to ask sort of the natural follow-up question, and maybe it might be a little silly, but one, does this type of tool not exist already? And if not, why not? Has it been the complexity of the different sensor data? Is it kind of integrating all this different type of hardware? What has been the challenge so far in having this type of tool available to engineers?
Yeah, I think there's a couple aspects to it, but fundamentally, the whole idea of observability isn't necessarily super unique. It's been around for a while. If you think about it, a lot of observability companies, they started basically around in the 2010s. A lot of it was driven because people moved to the cloud, and then suddenly you have these very complex cloud environments where you might have some mission critical or effectively mission critical type of application, like let's say Walmart.com, and it's running in the cloud. And then suddenly when something goes down, you have this really complex environment with all these different apps, all these different dependencies, and it's all actually failing because some little web app that an intern deployed 4 summers ago. So observability is a big thing in the broader market. The challenge is that the idea of observability hasn't really been huge in hardware as much, because you have to really, if you think through this problem at first principles, every single step that Austin mentioned is a lot different in hardware. So as you mentioned, the data that you ingest alone, you have way higher sampling rates. When you have a website, you might have let's say max 1 data point per second or 1 data point per minute, even about the server memory or something like that. Whereas when you're talking about firing a aircraft engine or a rocket engine, you're collecting data like 10 kilohertz, 50 kilohertz even at some of our customers. So you have high sampling rates of data. And then the other issue is there's a lot of like technical issues with getting this data in, like the fact that a lot of the companies we talk to, they can't even do a lot of the cool application layer stuff and analytics that we talk about because they can't even get the data in one single source of truth. For example, you have this really complex challenge when every different subsystem, like let's take a satellite, there's 20 different subsystems, the propulsion team, the GNC team, the flight software team, and each of their subsystems, like one piece of hardware, it might have thousands of different channels. A channel is like a sensor, or like even if it's a derived sensor value, and those might change with every software release. So then suddenly when you try to use traditional databases designed for the IT world, then you're going to be dealing with like database migrations and other sorts of issues. So like at Sift, we built this like pretty slick, like schema agnostic ingestion system that can basically dynamically adjust and like you'll read in these schemas as they change. And it might be as frequent as like every software release that you're deploying every day. You might have changes in these schemas and you can avoid doing all these migrations. And that's just on the ingestion layer. And then on the storage layer, the optimizations that the optimizations that we do are very different as well, because instead of loading data where you're looking at it over a long period of time, where it can be very downsample and you're looking at like longitudinal trends, you actually care more about, like, if you're trying to debug an issue with your aircraft engine, you might be zoomed in down to the millisecond or even smaller, and you want to see every single data point. So the optimizations you make for your database there tend to be more around query speed. So that's actually why we built our own storage product. It's called SiftDB. And it's pretty much this entire infrastructure layer designed for hardware sensor data. And it's really the only thing on the market. It's only offering on the market for working with hardware sensor data. Well,
and is there an element of like data compression there that enables like reduced cloud storage costs?
Exactly. So it has to do with the way we store the data. Austin, I don't know how deep you want to share about that, or.
Well, I think it kind of just goes back to what I was referring to earlier, right? Which is when you have insights about data access, you can store data in more appropriate storage classes that save money. So if you think about how a database typically stores data, it stores it in block storage on the cloud, which is much more expensive than other storage classes. So why keep all of the data ever that you probably will not look at in that storage class and indexed on top of that?
So what are the and sorry, actually, Karthik, I didn't let you finish. So storage, ingestion storage, Keep going.
So that's all just SiftDB. And then there's a Sift Visibility Suite, which is like the idea of visualizing data is nothing novel, but then you start to realize that what about when your users are technicians, they're hardware engineers? We had Elon at SpaceX. None of these people are writing SQL queries and Python to pull up their data. And I think there's this like common misconception. A lot of times people see a graph and they think a graph is a graph, and then they think that they can use something like Grafana to go visualize this. But really, that tends to really only scale for like the software engineers or the IT folks. And the way we see it is Grafana is kind of like a check engine light. But what do you do when the check engine light goes on and you have to actually debug and root cause what's going on? That requires actually having access to all the data, historical data, being able to compare data over timestamps, and being able to quickly root cause issues. And that's what Sift does. Sift is used for root causing these anomalies very quickly. On the visualization side, I mentioned that there are the constraints when your users are need a no-code interface. On the and then there's like a lot of other downstream things that we basically designed more for like hardware workflows. Like how do you actually data review this at scale so that people aren't writing Python scripts and manually review and make sure things are operating nominally. Like a lot of those things as well. They're driven more by the same constraints I mentioned earlier with the database, so I won't go into them. But effectively, what we're doing is like not necessarily. I guess the concept of observability isn't necessarily new, but making it work for hardware sensor data is what hasn't been done before due to these types of data constraints.
So, a company that's not using Sift, what are they doing today? Are there internal tools now, like SpaceX? SpaceX, I'm sure, has its own. They're known to always develop whatever they need. They develop internally. But like, a less well-funded company or business, like what are they doing? And like, what is your sort of value proposition when you're sitting in front of a company? Is it like, it's some, I guess, element of it's cost reduction, element of it's time reduction. Maybe how do you kind of measure that? How do you help quantify that ROI for a company?
Yeah, of course. I mean, there's a few different vectors for this, but not like beyond cost. There's also just risk reduction as well, because the thing is that everyone knows you need to go test your machine. And the thing is that testing process is very time consuming and very painful. And the talent that you use to go do that type of testing many times tends to fall in the flight software department, which what we've seen in the market is that flight software and GNC tend to be the hardest roles to recruit for right now. And suddenly you're wasting one of the scarcest resources reviewing and making sure that things are operating nominally, all because all because of the tooling and processes and the way you do this. And what ends up happening is you end up with very lightweight testing. It's more like, hey, we're just going to do a final test before we fly. And they realize like a config is missing, a LiDAR is turned off, and you're suddenly having issues where you can't figure out how to land on the moon, or you realize there's some sort of software bug. And a lot of this testing, the way we caught this type of stuff at SpaceX and what we do with our customers is you actually just run a lot more tests. So for example, instead of just running these things right before you launch and then making sure that it operates and you like review the data before launch, what you actually want to do is do the same type of testing on the hardware test stands. Like sometimes people call them hiddle tables, or like flat sat. And then even earlier, you can then bump the order of magnitude up even higher to like sills or hoodles or simulations, depending on what your company uses. And the idea is you effectively want to scale up the number of tests, because that also provides more opportunities to catch the issues and the failures. The problem is when you run all these tests, who's reviewing all that data? And with Sift, what we do is we automate that data review so that you can scale up the number of tests and then still review it and capture those insights and surface risks.
How do you make sure that during the ingestion process, like there's data that's not lost or kind of overlooked?
So there's,
it's all in the architecture
right.
of the application.
Yeah.
Right.
Okay.
So it's like all about redundancy. So everything from the point at which the data is sent to us, ensuring that, we've built rich client libraries that our customers can use that will ensure that if they're unable to send us data, that data is persisted locally or on their device so that when they can reconnect to Sift, they can send it to Sift. And then once we receive it at Sift, we have kind of multiple tiers of storage. So everything is always written to multiple places, at least for the first, hours and days at which we receive it, so that if we have to disable parts of the application or there are problems with parts of the application, we know for sure that we have their data and that we will be able to pick up where we left off when we restore service to the system. So a lot of it is kind of inspired by some of the work Karthik did on Dragon with respect to fault tolerance.
So Mo, sorry, I was struggling to interpret your question though. Was it more on like the technical aspect? How do we make sure that we don't lose the data? Or was it more about like, how do you make sure that all the tests and the insights you're like the potential insights you're generating are not lost or ignored?
Yeah, it's more the latter.
Okay.
No, sorry.
No,
I think from a technical perspective.
Part of this is actually, it's about reducing all the noise. So the idea with Sift is you actually want to automate the data review. So the idea is all these like nominal scenarios, tests, things of how it should behave, you should be instrumenting it and saving it as rules and checks that you don't have to go check those. And when all the nominal performance is fully instrumented and automated and you can trust that it's going to be caught, then you can shift your attention to all the off nominal things and actually investigating, hey, this looks a little weird. This looks like it's a little off. So for example, with Dragon, what we would do is actually something like 300 something off nominal scenarios and tests before every single mission. We had like 8 missions a year. Or I think we're averaging about 8 Dragon launches a year. And the thing is that when you have trust in your system to catch all the nominal performance, then it's much, you can focus your attention on just seeing what are like those weird behaviors and things that you wouldn't have expected.
So I want to pose a hypothetical, just kind of curious, like the user experience. So like take a satellite constellation. Typically you have like, one operator managing a constellation. Like what is that, how does that look like? So obviously like, how do you create that efficiency that allows someone to look at, for example, an entire constellation and say, I mean, maybe walk through sort of like what that user experience looks like kind of live.
Okay, so that's interesting. So you're asking the question more from like a space operator and their and like with Sift. So actually, I would say primarily Sift is used more in the like the R&D, the design.
I see. Okay, so testing, building. Design, R&D. Okay, I got it.
So the idea with that is actually, so this actually kind of gets with like, I guess like zooming back here. I think the idea with Sift is the way we kind of think. It's like the whole idea is to capture all this institutional knowledge into the tool. And one of the challenges is that like every time you change and you have to do knowledge transfer, like between a hardware engineer to a software engineer to someone who's an operator, then it's kind of like heat transfer, right? Every time you change forms of energy, you like lose a large percentage of it to heat. So the thing is that same thing with knowledge, where let's say you have an avionics engineer who's working on the power system with a solar array and some batteries, and they understand the performance envelope of this part inside out. And they have to go to a flight software engineer to go instrument the system and then say, this is how it should behave in this scenario, this is how it should behave in that scenario. A lot of the nuances of how that thing will behave, let's say at like a specific sun pointing mode or something like that, a lot of that is lost. And the thing is that by the time that flight software person then hands it off to a space ops, like a space operator, then I don't even know what there's like, just imagine how much knowledge is lost throughout that. So the idea with Sift is actually, instead of having and relying on like the flight software and these other downstream folks to go instrument the machine, you actually have the person who built the machine in the first place and understands those components inside and out. You have them go capture their insights as rules within the system, and they can say, in this scenario do this, in that scenario do that, and that will live with the machine, and that institutional knowledge lives with it, even if that person eventually leaves the company and just like attrition is very natural. Those insights live with the machine and it's completely automated. So by the time it's in the field, this piece of hardware actually kind of knows how to respond and handle a lot more. So you don't necessarily need like a space operator as much in the loop trying to monitor every single thing and see where it's all going and like control a joystick and like it's like in the movies where you're trying to like avoid a satellite collision or something. Like I think the idea is like you can capture all of that into the tool so you don't need to do it downstream.
Okay, so taking the product hat off for a second, you guys raised funding. We'll talk about that in a second. Like, tell me a little bit about how you think about demand for sort of real-time telemetry data solutions in general, right? Evolve, like maybe talk about it within the confines of like A&D, aerospace and defense, and then what are there other industries that you're looking at beyond A&D, and what does that look like?
Yeah, sure. So I would say about half of our customers are in aerospace, and the other half are actually pretty broad outside. There's aviation, energy, transportation. So rather than grouping it by the vertical in that like the industry vertical, I would actually group it more by like the depth of the pain point. So for example, you might have on one spectrum like a human-rated spacecraft like Starliner, Orion, Dragon, and then on the simpler side, you might have like a thermostat. And it tends to make more sense for us to focus on areas where there's these mission critical machines, things that are more complex. Like your average plane nowadays has close to 1 million parts. So those tend to be a much better fit for us. And that's how we're organizing our focus as well.
And can we talk for a second then about competition? Like I know you mentioned that the reason why this product exists is because you saw a gap in the market, but is there anything else out there that or other players offering custom built solutions? Like maybe tell me a little bit about what the market looks like from a competition perspective.
Yeah, of course. So our primary competition tend to be in-house tools. So and that's a spectrum like between purely custom in-house tools at the enterprise scale down to kind of like piecing together open source IT tools like a Grafana or like, and then a database, like a time series database. So that's typically what we see in most of our cycles.
Got it. Okay. And then revenue wise, maybe tell me a little bit about the revenue model. Like how do you guys work with companies? And then also talk about like, you mentioned like you group sort of the end customer really based on pain point, but like at what point or maybe give us the profile of when a company should be working with you. Like what does that look like as well?
Yeah, of course. We have customers that are actually the whole spectrum. So we have some really sharp startups who know how painful this is going to be. So they're happy to invest and just hand this off to Sift. So we do have some startups that are there, but most of our companies, I would say, tend to start more like the mid-market through the enterprise. And that tends to be when they start having cloud bills that are out of control. We have some companies that you'd be surprised that are in multi-million-dollar cloud bills, and they might only have one or two vehicles out in the field. Or if they're starting to allocate dedicated engineering resources. So a lot of times it seems like a problem you can bite off yourself. We'll just put together we'll put this together, this like InfluxDB, and then we'll throw Grafana on it. And then suddenly we're adding a data pipeline, and then we're having this caching layer, and then we're having to do this type of tooling to interact with it. And then my favorite is someone who they use LLMs to write, because their users are not able to write SQL queries into Grafana. So their users use this like LLM to write the SQL query to go then interact with the tool. It's like, well, why don't you just use a tool that you don't need to write code to go interact and find the data with? So typically when you start seeing yourself dedicate like half to full engineer, literally just managing all this data and the data pipelines and the tooling to access it, that's when it usually just makes sense to switch to someone our company has 30 people focused on solving this every day. So just hand it off to us.
And is the client base primarily commercial?
Yeah. Well, we have commercial companies that are doing work for the government, but I think I would still call them commercial.
So there are a few customers that you've named publicly. Companies like Parallel Systems, K2, True Anomaly. Maybe talk a little bit about like sort of their specific challenges that those companies were facing and how your tools improved their operations. Using kind of live examples to the extent that you can share.
Yeah. I mean, I think I can use all the live examples without saying their names. But I think like one of them, there is this whole issue with like the data pipeline where they had all these different subsystems that were generating their different schemas with every software release, and they had to deal with like all these database migrations. And I think they got to the point that they were spending about 1/3 of their cloud bill, and this is a multi-million-dollar cloud bill. They're spending like 1/3 on their cloud bill doing all these transformations, which is kind of crazy because that's not even like storing and working with the data itself. It's like just organizing the data to go in and get stored, which is kind of crazy. And then that's on like some of the infra side. Austin, do you actually want to talk through some of the other stories? Are there some other stories that like stand out that you think would be worth bringing up?
I mean, when I think of like a few of these customers, Karthik, that's a good example. One customer who transforms their data, takes hours for them to see their data. It's very expensive because they use a lot of compute to do all that transformation. Another customer on the infrastructure side, they were using a database that wasn't the correct type of database to store this type of data. And they were spending tens of thousands of dollars per month using that database. And then they built their own tool on top of this. And typically when you start building your own tool, you only get so far. And like the first things that you're trying to solve are visualizing data. So we come in with much more than just purely visualizing it, right? And I think, K2, for example, they joined us pretty early, so they actually did not have a solution for this at the time. But they knew, having had this experience at SpaceX, they knew they would need a solution for this. And part of the value of getting started really early is they can integrate Sift with their systems early on. So there's no migration cost. So for them, that was quite easy.
And they don't have to hire the application software engineers or people or like a lot of times people will like shoehorn a ground software engineer to go manage this, saying this looks like it's software on the ground. And then suddenly you're wasting the ground software engineer's time managing all this. There's actually one other one that I thought would be worth calling out, which is just a software release cycle. So one of the customers that we have for them to release software to their vehicle, every time they made, like, they would have to basically batch this into a release, and then you have to review this release. So the typical process is like you write all the software, it's on a branch, and then what you want to do is you want to test all of this in like a few different scenarios, like nominal and off nominal scenarios, let's say like 30 of them. And then you're going to release them to the vehicle once it's all good to go. And the thing is that for them to do that, the tests they can run overnight in like 10 hours or something like that. But in the review process of like scrubbing through and making sure, hey, did the current stay where we want it to be? Did the voltage behave as we expected? When we opened this actuator, did it behave as you expected? Did the battery drain in the way we wanted? That process took them 2 weeks, which is crazy because like that means that for every software release, like 2 weeks just before you can release it, then what ends up happening is that you're not going to do software releases that often, which also means that you're going to have bigger releases, which is more risk in each software release. Or you skip the releases until you get to production, which is also introducing a lot of risk. So at Sift, what you can do is move all that into, move all those rules and checks, kind of like how when you write a unit test for code, we're effectively like a unit test for the telemetry. And when you do that, then suddenly that becomes automated. And when it becomes so easy to test, instead of only testing before you do a software release to a vehicle, you start testing every single like simulation. And then it gets to the point that every pull request of code that you submit, you start running a full suite of tests on that. And this starts getting you to this idea, or this like the holy grail of testing, which I think we've all heard is test like you fly. So the idea is you're using the same test suite on your telemetry, whether you're in the field, whether you're doing a hardware test, whether you're doing a simulation, or even just a pull request of code to a development branch. So that's really the big value prop that I think people get very excited about.
Austin, I'm going to direct this question to you. Like, and Karthik's alluding to it a little bit, but like, what's next for Sift? Like, are there upcoming sort of product features, market expansions that you can share that you're kind of excited about, or kind of milestones that people should be like looking out for?
Yeah, it's a great question. I mean, I think so much about our technology and product. So as far as that goes, there's plenty of work to do. A big push for us is to meet the customer where they are with respect to deployment environments. So whether that's, running Sift in your cloud, running Sift in your data center at your site, or running Sift, a version of Sift on your vehicle, that's kind of the holy grail of what we're moving towards. And as Karthik mentioned, test as you fly, this rule set that you've developed during your development process, being able to port that rule set to your vehicle, and have those two things match so that the same rule set that's running on your test and your manufacturing line is also running on your vehicle, is kind of like big picture where Sift is going, or at least Sift DB and the Sift data analysis stack is going. So really excited about that. And then for me, like personally, what's gratifying is addressing some manufacturing use cases. So I worked on a lot of manufacturing software at SpaceX, specifically tracing parts through the manufacturing process. And I think there's a really interesting application of this software where we can understand the life of a part as it moves either through the test and manufacturing process, and then is like removed and installed onto multiple vehicles. So we have one customer who is aggressively pushing us to think about how Sift works on the moon. So that's one that's like an edge use case. But also then if Sift's on the moon and they're doing maintenance on their vehicles that are on the moon, how do they understand whether or not a battery is performing well enough to be installed to a vehicle? So I think that's kind of what gets me excited about where we're going with the product. And then of course, like I'm always eager to see how we can help other industries move just as quickly.
What keeps you guys up at night? Is it that, hey, this company is relying on our product during their R&D cycle to like build something great, and then something gets missed, or is it like something totally different? Like what is keeping you guys up at night as founders right now?
I'd say for me, it's data volume. I saw this at SpaceX, right? So when the team first built an application for Starlink, the data volumes were quite small, or I guess relatively small to what it is now, and that was keeping the team up at night. And now we're doing the same thing, and we started with one customer, and now we are at many more customers, and they're going to generate increasingly large volumes of data. So how do we continue to service them? That's just going to be a battle that we keep fighting. But we're just getting better and better at it every day.
Karthik looks like cool as a cucumber. He's like, I sleep through the night every night. I don't know what you're talking about.
The Austin cloud bill is what keeps me up at
night. Well, okay. So I want to talk about. You guys just recently raised a funding round, about $17.5 million, led by GV. I want to talk a little bit about that funding process. One, maybe talk about what does that bring your total cap raise to, if you can share. Two, what was it like going through that funding process? I know there's been as of the last couple of years, there's been this influx of various types of software for hardware type businesses. There's been a period of time where it's been more from the investor perspective that doesn't spend a lot of time on this. There was a lot. There's hard to differentiate. How did you guys get GV to come in and say, this is the company. We want to lead it. Maybe talk a little bit about that funding process. What was that like?
Yeah, of course. So I'm trying to think which part to start. Overall, I can just go through timeline. It was and then why they were interested and were excited about Sift. But timeline, I think it was a little bit different than what you would have expected from the traditional process. We actually didn't run a process. We met with Crystal from Google Ventures, and she it was just a typical casual 30-minute chat. We actually didn't speak too much in depth. I think it was more high level things. And then a couple months later, she actually came back with this 17-page list of notes that she took about the space, our company. She already diligenced us with some of our customers, which they kind of explained what was the value prop of Sift, why did they choose Sift over other alternative products. And she was like, this is a really interesting space. You guys are clearly the winning company in the space. So then she was like, how open are you guys getting preempted? And it was still I think a little bit being coy and let's just spend some more time. Let's go into it. So she flew here from New York, sat down and spent the whole day with us. We went through the whole business, talked about risks, how we're going to mitigate them, how the company is growing. And then the next, I think it was a couple of days later, we had a partner meeting with the Google Ventures partnership. And that was also, they just knew the way to an engineer's heart, because out of a 1-hour partner meeting, I think we spent 45 minutes talking about the technical architecture of our system and the infrastructure and why this whole problem is an infrastructure problem. It's not a web app type of problem. And realizing that we built all the right differentiated IP to go solve this, it's something that is going to be very difficult for our customers to solve. And it's something that SpaceX has been working on for over a decade internally. And I think that's where they got, they had a bunch of this conviction to invest. And we had a term sheet that afternoon, and I think it was a pretty easy choice because I think or at least what I appreciated, Austin could add some on his take, but what I appreciated is just someone who does the work, seeing someone who spends the time to really understand this and not just check the boxes and do the diligence calls with the people who are, of course, are going to say something good about you, but actually really dig into this and from a few different angles and understand it inside and out, and just come back with 17 pages of notes and research. I think that's how it's done, and it was a pretty easy choice to go with GV.
Doesn't sound as stressful as the other times I asked this question.
Well, you asked about our Series A, not our seed.
Yeah, that's fair. That's fair. That's fair. Well, what's next on the funding side? Do you guys have plans, or are you guys kind of at this point just heads down building?
Sorry, Austin, did you have anything to add on YGV? Or
well, I just wanted to double down on the the infrastructure side, and I think you asked a bit about differentiation, Mo, from other hardware for software businesses, and we're not converting what is traditionally an Excel worksheet into a SaaS product. We have differentiated IP at the infrastructure layer, whether that's storage or data analysis, that is actually key to making the SaaS part of the business work. Because if we were just selling a front end to these customers, as Karthik highlighted multiple times, they don't understand the data problem as well. And if you have a slow database, it makes the entire user experience bad. So, and I think Google understood that more than a lot of folks do.
What's the long-term view for Sift? Is it like, I mean, you're alluding to Sift on the moon, but like maybe tell us a little bit about what things look like over time. What are you guys going to be doing for the industry?
Yeah, I mean, I think it's more about solving all the adjacent problems that are associated with this. So not just when we started, we actually initially said, hey, let's go build like the visualization and the data review tools. And then, of course, we realized that one of the biggest issues to solving all this is the infrastructure. There's a lot of adjacent challenges that are also associated with just building complex machines. So one is like solving some of those adjacent problems, and then also doing it in a way that works for hardware. So I think what's next is going to be more about solving some of those other use cases, working with partners to solve those use cases, and pretty much offering a comprehensive suite of the tooling that's used to go build hardware companies.
So my last question is for both of you, which is outside of Sift, what is a company that you really admire in the startup ecosystem within A&D that you guys really like, really admire, you might even consider working for one day?
Oh, I can go because I don't want Austin to take mine. So I'll go first. I think that's, I would say K2 Space. He's like, I was going to take that. I think K2 Space. I think Karan Kunjar is like the CEO I aspire to be like sometimes. Just cool, has his act together, inspires a lot of confidence, and they're solving a very hard, I think it's interesting because they're solving this in there's multiple vectors. One is like the commercial, I've seen a lot of teams have strong go-to-market and they struggle on the engineering, then other teams that struggle on the engineering teams that are basically reversed. And it seems like they're moving all beats forward and they're going to be able to solve big things with the overall platform that they're building.
Austin, is that your answer, or did you have something else?
Well, I know. I mean, the thing is, we see a lot of customers, companies, right? And I think something that I really appreciate about the K2 Space team is they have an incredibly, K2 Spaces, they have an incredibly strong team. And they also have been able to take Sift and run with it with very little intervention from us. I just think, this idea of building kind of mega satellites is bucking the trend of LEO constellations, and pretty cool or pretty exciting to see like a massive satellite on orbit. So I would say the same thing, but I guess
all right,
answer.
I'll accept. Okay, well, gentlemen, it was a pleasure having you both on the show. Thanks so much for being on it. I might ask for a new remove before flight tag from you guys at some point if you guys still do those.
Oh, we do. They're actually so I think what was unique about ours is that they actually said ready for flight.
Oh, ready for flight. Yeah. It did say ready for flight. That's exactly right.
We do.
By the way, what's funny? I actually part of the reason why I never was a big fan of like the remove before flight, because I'm like, someone's gonna someone who doesn't get the reference, especially I don't know, you see a baggage handler, he's like looking at this, he's like, remove before flight, oh maybe I shouldn't be going on to this. So I have this like paranoid fear that's someone will see that it's like this bright red tag and remove my suitcase from the baggage area, and I'm just like, wait, no, that's not what I want. But actually, I remember what I liked about your guys said. It said ready for flight. I was like, okay, this can't possibly happen here. So I appreciate that. But anyway, thanks, guys. Really appreciate having you on the show. Until next time.
Thanks, Mel.
Thanks, Mel.